So let's graph lines using the form or standard form ax plus by equals c. Let's say we have a linear equation 3x plus y equals 6, and we want to plot this line or equation as a graph shown here. So we're going to take this expression, we're going to take the simplest points. Basically the simplest points is where we have x equals 0. So when we substitute x equals 0, 3 times 0 is simply 0, plus y equals 6. Therefore, we have, for corresponding to 0, a point in y where it's equal to 6. So we have coordinates 0 and 6, and we plot that line. So here we have 0 for x and 6 for y. And so that's our point right there. And the other point is when we substitute y equals 0. So when y is equal to 0, we just substitute y equals 0 in this equation. Now we have 3x equals to 6, shown here. We divide 3 on both sides of this equation. 3x divided by 3 just yields x. On the left side, 6 divided by 3 is equal to 2 on the right side. So we have, for x equals 2, we have y equals 0. So 2 and y is 0. We have another point right here. Now it takes 2 points to determine a line. So therefore, now we have these 2 points, we can draw a line between them, through them. And there we have it. We can check by substituting x equals 1. So here, x equals 1 into this equation yields the following. 3 times 1 plus y equals 6. That yields an answer of y equals 3, since we subtract 3 on both sides of this equation. Here the 3's cancel out. 3 minus 3 on the left side equals 0. And then 6 minus 3 equals to 3. Now we check to see if that fits in the graph. 1, 3. So 1 and 3. And we see that it visually looks like it's correct. So therefore, we can say that we graphed the line properly through these 3 points. But it only takes 2 points to determine a line. So once again, the way we do it is start off with these simplest point where it intercepts the x-axis, where we substitute x equal 0, and that gives us a y value of 6. Likewise, when we substitute y equals 0, we get an value of x equals 2. Alright? So here we have the x-axis intercept of 2 and a y-intercept of 6. Using the slope-intercept form, where m is the slope and b is the y-intercept, and we'll see y is called the y-intercept. So let's start off with this equation. We can see that this equation is in slope-intercept form since y is by itself, and we note that anything in front of the x in this form is the coefficient is known as the slope. Alright? And then the constant here is known as the y-intercept. So let's do it again. X equals 0. When this is x equals 0, we have minus 2 times 0 plus 6. So we substitute x equals 0 in this equation, and we have the following point, 0 and 6. So for x equals 0, we plot y equals 6 right here. Okay? Now we're going to substitute y equals 0. Okay, so when y is equals 0, we have our following relationship. And using algebra, subtracting 2x on both sides, we get 2x equals 6. And then dividing 2 on both sides, 2 divided by 2 yields x. And 6 divided by 2 equals 3. So our third point is 3, 0. Okay, this is our x-intercept. Alright, because it intercepts the y-x-axis at 3. Alright, and here we have our y-intercept 6, so that's why B is called the y-intercept. Now we take these 2 points and plot a line through them. And as before, we can check it with another point. It could be any point. X equal 1 in this case will do. So negative 2 times 1 is negative 2 plus 6 equals 4. So our point 1 and 4 should fall on the line. So looking here, we go 1, up 4, and we have our third point. And that's how we graph our line. Again, the coefficient in front of x, negative 2 in this slope-intercept form, is the slope. Here our slope is negative 2. Why? Because if I go one step here, starting from r, so at 1 and we go to 2, we go down 2. So this is a negative slope, but we can talk about this more in detail in the upcoming video. But I just want you to note that when we put this in this form called the slope-intercept form, we get 2 variables. One is known as the slope. You can see that this is negative slope. And then the y-intercept 6. And we'll discuss that in a later video. Now let's look at an application involving linear equations. And in this case we're going to discuss the wind-chill factor. And let's say the wind-chill factor is governed by the following relationship, where we have W is equal to 1.3 times T, where T is the temperature, and we subtract that product with 20. Now we'll substitute T equals 20 into this equation. That yields the following wind-chill factor equal to 1.3 times 0 minus 20, or simply W equal minus 20. That gives us an ordered pair of 0 and minus 20. So we plot that point on this graph as follows. We can try another point, since it takes 2 points to determine a line, where T is equal to 4. Substituting again in the above equation yields the following wind-chill factor equal to 1.3 times 4 minus 20, or a wind-chill factor of negative 14.8. Now that yields an ordered pair of 4 and minus 14.8. We plot that point on this graph, and since we have 2 points now, we can draw a line through them. We can check this graph by plotting another point, negative 4, and then negative 4 is substituted into the above equation of 1.3 times minus 4, subtract 20. That yields an answer of W equal negative 25.2, plotting T equal minus 4, and then negative 4 equaled negative 25.2. And then we can see the third point falls on that line. And that includes all these 3 points falling on this line, and that concludes the application involving linear equations with an application to the wind-chill factor.